So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over a GCSE stroke AS level maths topic of quadratic inequalities. Now we'll include some notes and a worksheet with a set of answers so you can practice everything you've learned in this video to see how much of it you understand. Now before we start talking through quadratic inequalities, I think it's really important that you're able to understand some prior topics, as quadratic inequalities is often taught later on in the GCSE syllabus, but also at the start of A-level maths once you've done quadratics. Now upon understanding this topic, you need to be able to make sure that you understand and be able to read inequalities and how to show these on number lines. You also need to be able to solve linear inequalities where you've just got a single x. You also need to be able to recognize the shape of a quadratic equation when it's plotted, so either a positive or a negative parabola, so either a happy face or a sad face. You also need to know how to solve a quadratic equation, and that's from using both factorizing and by using the quadratic formula, and when the coefficient of x squared is greater than 1. If you're not sure what coefficient means, it basically means the quantity of the x squared, so how many x squareds you've got where it's usually more than 1. And you also need to be able to rearrange the formula and collect like terms, and those two topics tend to come in for more complicated quadratic inequalities. So before we get started, let's just have a look at the main differences between solving a quadratic equation and solving a quadratic inequality equation. And the main difference is the fact of what the solutions look like. Now when you are solving a quadratic equation, it all depends on whether the type of equation that you have got. Now, if we dealt with positive parabolas, you're either going to end up with two solutions, which I would say is more common than anything. You may end up with, let me just write two solutions there. And if we had two solutions, we'd have x equals, and we'll have a number, and then we've got another number, in which we would just call that a and b. So that will be a, and that will be b. We could also have a positive parabola where we've only got one solution, and that's where the x-axis is going to be a tangent. So that's just one solution, in which we'll just write x equals, and if I just label that point C, it would be C. And we can also have a positive parabola which has absolutely no solutions. So here we've got x equals, and then basically we've got no solutions. The reason why it's got no solutions is because it doesn't cross the x-axis. And the same kind of applies when we've got negative parabolas. So again, we could have two solutions. We can write it, in which we've got x equals, and then we've got a and b. Or we could have one solution, in which our answer would look like x equals c, and we can also have no solutions where it doesn't cross the x-axis. So here we've got equals when we've got a normal quadratic equation. Now how it differs with a quadratic inequality is the fact that we could end up with a range of values. Now I'll only just do this where we've got two values. So let's say here are our solutions, which is a and b. Now with a quadratic equation, your answer could either be this set of values or this set of values, which tend to call like sideburns. So here we could end up where x is less than a or x is greater than b, or we could end up with this middle section, which we could call chin fluff. And so there we've got a range of values where x is between a and b, and that's generally what your answers will look like. It will look like either one of those two depending on what you're dealing with. And likewise, you could end up with something where we've already got one solution, and again from this it's a bit more complicated. It's highly unlikely to end up with one solution. More often with quadratic inequalities you generally end up with two solutions because the answers kind of make more sense. So now let's have a look at the method to solve quadratic inequalities. Now, I would say that most of these questions do not carry 6 marks, but depending on the type of question and whereabouts it is and how many marks are available, you may have to do something to do with each of these steps. Now, as I've said, the lower marks some of these steps will be done for you, but it's just worth just checking. Now, if any of these steps do not make any sense, do not worry. When we start working through examples, hopefully these steps will make sense. And sometimes it's really difficult in maths to kind of describe in words what you're doing without actually doing it. So the first step is basically, like with all types of quadratics, is you want to make sure that it's equal to 0. And here, so if you make it equal to 0, not replacing the equal sign with the inequality, and try and keep the x squared positive, but this isn't really important. So obviously you can end up with negative parabolas, but what you can do is just shift everything onto the other side to make it a positive parabola. Because remember that your solutions are going to be a set of values, and it doesn't really matter whether you're dealing with a positive parabola or a negative parabola, the values will be the same if you've done it correct. Now, if the 0 is on the left-hand side, what you want to do is move it to the right-hand side, reversing the direction of the inequality. Now, this is really important. So let me just give you a brief example of the first one. So in terms of the first one, if we had x squared minus 4x is less than 6, what you want to do is make that equal to 0. So we'd write that as x squared minus 4x minus 6 is less than 0. With the second point, if we had something that looked like this, choose a, well, that might appear better on your screen. So let's say we had 0 is greater than x squared minus 4x plus 3. Now, what you want to try and do, we can stick an equal sign, it doesn't really matter. But what I'm suggesting in this particular step 2 is to take this 0 over to the other side. Now, if I do that, then what I need to do is the main components of the quadratic equation stays the same. My 0 now is on the right hand side, but because I flipped the 0, I need to flip the direction of the inequality. So that now is going to be pointing to the left to represent less or equal to. So that's basically what step 2 then means. Step 3, it then says solve the equation for 0 by factorizing all the quadratic formula to find the solutions stroke the x-intercepts where x equals 2, potentially and most often commonly 2 values. So what you then want to do for this particular step is to actually then go on to solve it. So here I've got x squared minus 4x plus 3 is equal to 0. And does that factorize? I believe it does. So if I had x minus 3, x minus 1 equals 0. So my two answers there would be positive 3 or positive 1. For step 4, what we then want to do is to sketch the graph. So for this, I know it's going to be a positive parabola because I've got a positive x squared, and it's going to look something like this. Now, this doesn't really imply, actually, to be honest, what I would do is I wouldn't even do my sketch like that. Let's make this pen a little bit thicker. So here I'm just going to draw a horizontal line. I'm then going to draw a positive parabola. I'm not going to worry about the y-axis because that could make this diagram a bit invalid. I'm then going to write down my two values, which in this case are 1 and 3. So 1's going to be there because it's a smaller one, and 3 is going to be there. So in terms of drawing the sketch, that is what it's going to look like. And again, it didn't really matter if it was a negative parabola because those two values would be the same, but rather than having a smiley face, I would end up with a sad face. It then says if the inequality in step 2 is less or equal to, then highlight the curve that is above the x-axis. If it's less or equal to, then highlight the curve that is below the x-axis, and 0 must be on the right hand side, else the opposite will apply. So try and keep just this all consistent of having the 0 on the right hand side for this rule in step 5 to make sense. So here, if I look at the original question, which is this, just rearranged with the 0 on the right hand side, you can see here that I've got a less or equal to. Now, because I've got a less or equal to, I want the bits that are below. So I'm going to shade in this region here because that is the bit that I want. If this equation was greater than, so that was going in the opposite direction. So if I had x squared minus 4x plus 3 was greater or equal to 0, then I'd be looking at the bits that are above, the parts of the curve that is above the x-axis or the horizontal line. So I'd be looking for those green bits there. It then says if the highlighted area are two separate bits, your answer will look like this. So because I've got, let me just get rid of those green markers. So here I've got one part. So my answer is going to look like this. So it's going to look with x there, like so. And again, because the inequality is equal to, so this inequality here is going to be the same as this one here. And I'm just going to fill in the two numbers. So that's going to be 1 and 3. And there is my final answer. So again, all the important thing to note is that if the original equation has a less or equal to or greater or equal to, this should be included in your answer as well. So because obviously if I then, what that basically means is if this line disappeared, then this line would also need to disappear in the answers as well. Now, when it comes to the answer, in terms of number 6, your answer will either look like this, and the line underneath is going to be dependent on whether there is a line underneath in the question, or it's going to look like this. They're the only two possible formations of your answer can look like. So again, it's you're never going to have an answer where you've got like two numbers and the inequalities are pointing to the right, because that doesn't make any sense if you break it down. Nor will your answers ever look like something like where x is going to be let's say pointing in those directions of, let's say, 4 and let's say 3 and x like that. Again, it's unlikely. So your answer will only look like one of these two things, and that all depends on how many bits are marked in the question in terms of the diagram. How many parts of the curve have you shaded? And again, if this is making absolutely no sense, which I feel like it is, hopefully when we go through some examples now, it will do. So now let's have a look at putting those methodology into practice with some example questions. So looking at question 1, and most questions will generally look like this. It says solve x squared minus 4x minus 12 is greater or equal to 0. So here, if we go through the steps, now with this, there is no rearranging I need to do. Here you can see that my equation is on the left-hand side, my 0 is on the right-hand side, and my x squared is positive. And again, they're just more cosmetic things to make my life a little bit easier, and for what the method I've showed above is going to be the same. So for this, what we need to do first is then go on to solve x squared minus 4x minus 12 equals 0. Now you can do this from this stage. Once it's equal to 0, you can either use the quadratic formula or by factorizing. This one does factorize nicely, in which we've got the values of, and it's going to be 6 and 2. So I've got 6 and 2 equals 0, and I've got minus 6 and positive 2. So my two answers are going to be 6 or minus 2. Now the next thing for me to now do is to sketch. Now I know that y equals x squared minus 4x minus 12 is going to equal a U shape. So if I draw my horizontal line, draw a U shape, and I've got two answers, so it's going to cross at 2 points. And I can then label where these two values are going to be. So minus 2 is going to be here, and 6 is going to be there. And again, just to visualize a number line and just say where they're going to be. Now for this, I then need to now look at the actual question when it equals 0, when it's less or equal to 0 or greater or equal to 0. Now for this, it says that I want where the curve, and this represents above, and 0 is the x-axis. So once you've got it in this format, the equation represents the curve. Less than means below, greater than means above, and the 0 represents the x-axis. So here I want the region where the curve is above the x-axis, and where that's above is this bit here and this bit here. Now as you can see from what I've shaded, I've got two separate parts, which means I'm going to have two separate answers. Now here, I want this region here, so that's going to be x, and as you can see, that blue area, or that shading, is going in that direction, so it's going to be that with a minus 2. Now because the question, the inequality in the question has got an equal to, I'm going to put a line in the answer as well. For this one here, let me just not draw that arrow going there. You can see that the blue area is going in this direction, so I'm going to write x. My inequality is going in that direction. I'm going to put a line underneath it because there's a line in the question, and I've got the number 6. So my answer is x is less or equal to minus 2, or that x is greater or equal to 6. And again, I've got two separate answers because I've got two separate parts on my diagram. Moving on to question 2, it says again something looks very, very similar, but as you can see, the inequality is not only in the different direction, but it's also hasn't got that equal sign. So again, going through the notions, have I got it equal to 0? Yes. Is there 0 on the right hand side? Yes. Have I got a positive x squared? Yes. So then I'm now in a good position to then go on to solve this quadratic. So I start by first making it equal to 0 and then solve by either factorizing or using the quadratic formula, which this one does factorize. So I've got 4 and I've got 2. And they're both positive, and that equals 0. So I've got two answers of -4 or -2. And again, if I was to use the quadratic formula, it'd probably most likely be very time consuming and require a calculator in some cases. But again, I should end up with the same answers if you've done it correctly. So again, from this, I draw my diagram. This is going to be a U shape because my x squared is positive. And this one here on the left is going to be the smaller out of the two numbers, which in this case is -4. And this one here is going to be -2 because that's the bigger of my two answers. Now here I'm looking at less than the curve. So again, if I translate this, let me just get rid of this bit here. So reading the inequality, this bit here represents the curve or the parabola. This means below, and the 0 means the x-axis. So I'm looking for the region of the parabola where it's below that horizontal line, which is this bit here. So what I then do, because I want that region there, I want where x is going to be between -4 and -2, and there is my final answer. So again, you want your smaller number on the left, your bigger number on the right. And again, the reason why we haven't got two separate answers is because I've only shaded one part of that line. So now let's have a look at another set of examples. So this is where we've got a coefficient of more than 1 for x squared. But again, I solve this in the exact same way. So I want to do the checks. Is it equal to 0? Yes. Is the x squared positive? Yes. Is the 0 on the right hand side? Yes. So happy days, I could then go on to solve this. So looking at this, you can either, again, it's entirely up to you, you can either attempt to factorize it or attempt to use the quadratic formula. From my knowledge, I do believe this factorizes. So we want to solve it for when it equals 0. Actually, let me just write all of that. So what we need to do first, and it's very good practice for you to work with writing equals first. So I'm going to assume that I'm just going to ignore the inequality and go on to solve this. So I've got 2x and I've got an x equals 0. So I've got 24. So we're looking at 10 and no, 6 and 2 maybe. No, 4 and 3. 4 and 3 would work. And they're both going to be minus. So here are our two numbers. And so x is either going to equal +3/2 or +4. So from this, what I then need to do is now do my sketch. And again, if I use a quadratic formula, I should have ended up with those two values. And again, if you wanted to write 1.5, entirely up to you. So again, drawing my horizontal line, again, it's going to be a positive parabola. And these 2 points here, so the smaller out the two answers, so this one's going to be 1.5 and this one is going to be 4. And translating what the equation means, this is the curve, this means below, and this is the x-axis. So the bit of this curve where it's below the x-axis is this bit here, and as it's only one part, my answer is going to look like this. I need to put a line underneath because there's a line equal sign in the question, and it's just a case of filling in the two numbers with your smaller number going first and your bigger number going last, and there is my final answer. Moving on to question 4, again very similar, but this time we notice that it's not equal to 0. So what I need to do is take this 2 over. So I've got 3, we'll use a different color pen. I've got 3x squared minus 13x minus 10 is less than 0. And the 0 is on the right hand side, which is always good. So now let's have a look at solving this. So I'm going to solve 3x squared minus 13x minus 10 is equal to 0. This should factorize, so let's just double check, in which I'm going to end up with 5 and 2, and it's going to be minus and a plus equals 0. So here I'm going to end up with answers of -3/2 and +5. And again, if I was to use quadratic formula, I should still end up with those same values. So again, looking for a positive parabola. And I'm writing those two numbers, so minus 3 over 2 and positive 5. And again, looking at the question, I'm wanting where the curve is below and the x-axis. Now really I shouldn't be using that, I should be using this instead, but the same thing kind of applies. And so I'm wanting this region here. And so from this, all I've got to do is, because I've only shaded in one area, just get rid of x, all I've got to do is just put in the missing numbers. In this case, it's going to be minus 1.5 and 5, and there is my final answer. Again, I don't need any lines because there's no lines in the question. Now moving on to question 5, here we can see that the question is presented slightly more awkwardly. So here not only have we got negative x squared, we've also got our 0 on the left hand side, and typically with the previous 4 questions it's always been the other way around. Now what we're going to do here is we're going to actually swap these two things around. So here we're going to end up with, and by doing that, all that's going to do is going to change everything in that equation that's positive into a negative and vice versa. So I'm going to end up with 4x squared minus 4x minus 3 with 0 on this side, and because I've flipped the things around, I've got to now flip this inequality. So that, rather than pointing to the right, is now going to point to the left. And to make that a little bit darker. So now this is what we're going to do. So now I've got positive x squared, my 0 is on the right hand side, so we can now have got some happy days. So now what I now need to do is to go on to solve this. So here again, now what I'm going to do for this one is I'm just going to assume that it doesn't factorize. So let's use the quadratic formula. So here I've got minus 4c equals minus 3. And again, what I'm solving is 4x squared minus 4x minus 3 equals 0. So I'm using the quadratic formula. I end up with minus 4 plus minus the square root of minus 4 squared minus bracket 4 times minus 3. It's all square rooted, all divided by 4 times 2. Now simplifying this, and I'm going to assume that I haven't got a calculator, so that then becomes positive 4 plus minus 4 squared is 16. And then 4 times 4 is 16 times 3. That gives me an answer of 48. So it's going to be minus 48, all divided by 8. And then simplifying that even further, I get 4 plus or minus the square root of 16 plus 48, which is 64. All divided by 8. 64 square rooted is going to be 8, so I've got 4 plus or minus 8 over 8. So when it's a minus, I'm going to end up with minus a half, or when it's a positive, I'm going to end up with 12 over 8, which gives me an answer of 3 over 2. So there's my two solutions. So now what I need to do is plot. So I draw my horizontal line. Looks like this. And again, I'm referring to this. So again, it's going to be a positive parabola, even though the original equation was a negative parabola, so sad face, but because I flipped it, it's now going to look like this. And I'll explain where that comes from in due course. So looking at this, I'm looking for where the curve is below the x-axis. And let me just label these 2 points. So that's going to be minus a half, and this is going to be 3 over 2. So I'm looking for the region that is below the x-axis, which is this region here. So then my answer is going to look like minus a half x and 3 over 2. And looking at the inequality here, it's going to be less than. There's my final answer. Now, if I looked at the actual original equations, if I actually looked at this, and let me just get rid of all these markings because so if I took the original equation, let's have a look at what this means. So the 0 means the x-axis. This means above, it's greater than, and this bit here is the curve. Now, minus x squared means it's going to be a negative parabola. And these are my two solutions, which I've discovered are these two numbers here. So looking at the equation, it's actually going to give me this, in which it's going to give me the same answer. So here it's just a case of just reversing it. So that's why the method kind of works. Even if you do it without having to use and without having to rearrange it, it will still give you the same answer, because the answer is just a range of values, not how we arrange it. Now looking at question 6, it says solve 9x minus 2x squared is less than 10. So here not only have I not got a 0, I've also got a negative x squared. So let's just rearrange this formula to try and get our not only our x squared positive, but also try and get it with a 0. So for this, what I'm going to do is I'm going to take all of this over to the other side. So here what I end up is with 0, and then I've got 10 minus 9x plus 2x squared. And if I just neaten that up, I've got 0, 2x squared minus 9x and positive 10. Then what I'm going to do is I'm going to take the 0 over to this side. So then what happens then is I've got 2x squared minus 9x plus 10. And then the 0 is now on this side, so I need to flip the inequality. So I end up with something that looks like this. Now from this, what I now need to do is I just need to see if this factorizes, or I could use a quadratic formula if it's taking me too long. It does actually factorize, so I've got 2x minus 5 and x minus 2, sorry, and that equals 0. So from this, my two solutions are going to be x equals, and it's going to be 5 over 2 or positive 2. Now looking at this equation here, not the original, if I sketch this, I'm going to end up with a positive parabola. My two values are the smaller one first, which is going to be 2, and this one's going to be 5 over 2. And I'm wanting the region where it's above the x-axis. So I'm wanting this bit here and this bit here. So then, because I've got two separate bits in my answer, that's going to be x, and the direction's going that way of 2, and this is x, and the shaded area is going in that direction, so it's 5 over 2. So these two things here are my final answer. So the final answer for this one is going to be x is less than 2, or x is greater than 5 over 2. And there we go. Now let's now have a look at some extension questions. So this kind of where it goes into A level, but also you could also get it on high GCSE or even on level 2 further maths. So it says that the area of the rectangle must be greater than the area of the triangle. Find the possible range of possible values of x. So first things first, what we need to do is find the area of the triangle. And we do that by doing the base times the height divided by 2. So that's going to be 4 times x minus 2 divided by 2. And if I simplify all of that, I get 4x minus 8 divided by 2, and that equals 2x minus 4. So that there is the area of the triangle. Now working with the area of the rectangle, that's basically going to be the length times the width. So the area of, let me just make that a little bit thicker, it's actually a different color. Let's go for this one here. So the area of the rectangle is going to be x times x minus 3, which gives me x squared minus 3x. So that's the area of the rectangle. Now going along what it tells me in the question, it says the area of the rectangle must be greater than the area of the triangle. Now if I translate that using mathematical knowledge, the sort of notation, the area of the rectangle, which is this, so that's going to be x squared minus 3x, is going to be greater than the area of the triangle, which is this, so it's going to be 2x minus 4. So this is actually what I'm going to want to solve. So from this, we've got x squared minus 3x is greater than 2x minus 4. So if I take all of that over to that side to keep the x squared positive, but also to make it equal to 0, I've got 5x plus 4 is less than 0, greater than 0. Now this does factorize, in which I've got 4 and 1, minus and a minus, in which then I've got x equals 4 or x equals positive 1. Now, so looking at this, in terms of the possible values it could be, well, can x equal 1? Well, looking at this, it can't. So for this, if I draw my parabola, in terms of looking at the values, let's just substitute that in now, because x can't equal 1. as this would therefore be negative. So would this, and you can't have negative length. So the only value it can be is 4. So for this, if I draw my parabola, like I've done in the previous questions of working with this, here I've got 1 and I've got 4 as my possible answers, and I'm looking for values where it's greater than. So I'm either looking at this or this, but the problem is it can't equal this because x represents length, and that's going to head towards negative numbers, so it can't equal that. So the only possible answers it could be is where x is greater than 4. It can't equal 4 because then the area of the rectangle will be equal to the area of the triangle, so values of x must be greater than 4. So now let's have a look at another extension question, and this one says find the range of values of x which satisfy both inequalities simultaneously of x squared minus 3x minus 4 is greater or equal to 0 and 3x plus 1 is greater than 2x plus 6. So now let's have a look at solving these separately. So looking at this, we know it's a parabola. So if I then just imagine that, replace the inequality with an equal sign, and then just go on and solve this. So this does factorize 4 and plus 1 equals 0. So x equals 4 or minus 1. Then solving this, I get minus 1 and 4. Now I want it where it's greater than. So I want these values here. So solving this, x has got to be less or equal to minus 1, or x has got to be greater or equal to 4. So they're the possible two answers that I have got for this quadratic part. And if I then move on to this, in which I've got 3x plus 1 equals 2x plus 6, and then just go on and solve it. So take this over to the x over to the side. So end up with x plus 1 is equal to 6. So then x equals 5. And then if I then just replace the inequality with what it was originally, and so I've got x is greater than 5. Now what I want to do is I want to work out the set of values that satisfy both of these two things. So if I just imagine that I've got a number line, and I'm going to start at minus 1 because that's the smallest number out of all the ones that I've got left, or that in terms of the answers, and it goes all the way up to 5, but let me just go up to 6 just to make sure. Now if I take these set of answers, and let me just put that in blue here, so representing these answers on the number line, that's going to equal this, so going in that direction. Let me just extend that to put minus 2. And the other one is going to be this here, going in that direction. Now in terms of the linear one, so let me just do that in green. Let's now represent that in green. And that's going in that direction. Now I want the range of values that satisfy both. Now this part here doesn't contain any green numbers, so that's going to be a no-go. And looking at this, the only bits that are going to have both, the only set of values that are going to have both blue and green lines are numbers beyond 5. So my final answer, let me do that in a different colour. The final answer is for the range of values that satisfy both these two equations, or where x has got to be greater or equal to, or I would say greater than 5, and there is my final answer.